Hey everyone, it's that math magician. On this video, we're going to continue to look at statements, but this time we're going to focus in on the converse statement. We'll learn exactly what it is, why we have it, and then whether or not it creates a true or false statement. Now, converse statements are based on the conditional statements, what we learned in the previous video. Remember, all a conditional statement really is an if-then statement. Remember, we had if A, then B, right? If we have this, then we end up with that. We called A the hypothesis and B the conclusion because we were thinking, if I know this is true, then this is the conclusion, right? Now, what's really nice about the converse statement is that we take that conditional statement, right? If A, then B, and all the converse statement really is just swapping your hypothesis and your conclusion. It's really just changing those two positions to create a brand new statement. So when I have if A, then B, the converse of that would be if B, then A. Notice that I'm just taking the conclusion and the hypothesis and swapping their positions. So now you start with the conclusion. If you know B, then you end up with A. And it creates an entirely new statement where we still want to check whether or not is it true or is it false. Sometimes you might start out with a true conditional statement, but then its converse might end up being false. So that's what we want to check now as we work through these examples. Now, our first example over there for our conditional statement was if today is Monday, then tomorrow is Tuesday. We said that that was a true conditional statement because if you have today is Monday, then tomorrow has to be Tuesday. Well, then the converse statement of that conditional statement is just swapping the if and the then, right? The conclusion and the hypothesis. Switch them to create a brand new converse statement that says, if tomorrow is Tuesday, then today is Monday. Notice that the converse is just the conditional swapped. And we end up with a brand new statement where we have to decide, is it true or is it false? So let's look through it one more time. If tomorrow is Tuesday, so if I know tomorrow is Tuesday, then today is Monday. Yes, that is absolutely correct. That is a true converse statement. And you see there that we create just a brand new statement based off our original conditional statement. Let's go and work through a couple more examples. Actually, the examples we used in the previous video. And again, continue to look at, is it still true or is it now false? So let's go ahead and look at this problem here that we worked through last time. We had the conditional statement on the left that said, if today is Monday, then tomorrow is Sunday. We said that was false. We said that was not a true conditional statement. Because if today is Monday, then we know tomorrow is not Sunday. Now notice the converse statement is just flipped, right? If tomorrow is Sunday, then today is Monday. Now we have to think, is that a true statement? And I'm thinking about it, okay, if I know tomorrow is Sunday, then is today Monday? The answer for that is absolutely not, right? We know that if tomorrow is Sunday, then today is Saturday. So that's an example of a conditional statement that was false. I then rewrite it and get its converse, and actually still remains false, right? It does not work for us, so we know that that converse statement is false. All right, let's try another one. Another example of our conditional statement that we had last time, and whether or not its converse is going to be true or false. So now our conditional statement for this was, if the polygon has three sides, then it is a triangle. We said that was true. We said that if we had a shape that had three sides, then it has to be a triangle. Well, here we have its converse statement. And the converse statement is, if it is a triangle, then the polygon has three sides. And we want to think now, is that still a true statement or did it change to become false? And I think for this one, it actually ends up staying true, right? If it is a triangle, if the shape you have is a triangle, well, then the polygon has three sides because that's the definition of a triangle. A triangle does have three sides. So that is great. Awesome. Let's do one more final example problem, And this is the one where we had a conditional statement that was false, right? Remember that example where we said, if the area is base times height, then the polygon is a rectangle. We said that was false. We said it was false because if the area is base times height, it doesn't just have to be a rectangle. It could be a square, a parallelogram, or a rhombus, because all four of those end up using that formula. Well, now look at the converse statement of that original conditional statement. Notice that the hypothesis and the conclusion are flipped. And now I end up with this statement that says, if the polygon is a rectangle, then the area is base times height. That right there is a true statement. Think about that. If the polygon is a rectangle, then the area is base times height. That is true. Notice that when I take the converse, it switched from a false statement now to a true statement. And sometimes that might happen because by changing the order of that statement, now I'm leading with, I have a rectangle. If the polygon is a rectangle, then the area has to be base times height. It sort of removes those other options when we create its converse statement. And that's what converse statements are all about, okay? It's all about taking your conditional statement, flipping it, switching the order, changing the if and the then, and then just seeing if you still have a true or a false statement. It's that math magician, and I'll see you on the next video.